The topic to be explained in this video is IoT security tomography. IoT tomography. Tomography means examination. Examination. Security tomography in the IoT concept is classified according to attacks addressing to different layers. Consider attacks. Consider attacks addressing to different layers. Different types of these attacks are vulnerabilities of the IoT. Due to these attacks, disrupt the communication within the IoT networks. Different types of layers are there. This one is RF layer, MAC layer. This one is network layer and transport layer. These are the different layers, and each and every layer we have to examine some attacks. Due to these attacks, disturb the communication between the parties within the IoT networks. We have considered layers, namely transport layer, network layer, MAC layer, and RF layer, radio frequency layer. Consider attacks addressing to different layers. Now we will see attacks. What are the types of attacks which are classified at different layers? First one is threats on transport layer. This is the suppose transport layer. Transport layer. Generally, two types of protocols are used: TCP and UDP. Transmission control protocol and user datagram protocol. TCP is used for reliable communication. Before transferring the information from one point to another point, a path, this is a path is created between source node and the destination node. At the transport layer, disrupt this path by using some wrong sending the data, injecting the packets. Wrong information is sent from source node to destination node. Error information is sent from source node to destination node. At the destination node, check the transmission errors present in the receiving packets. Suppose error packets are sent from source node to destination node. Some at the destination node, these packets are received. Check the validity of these packets. If more errors takes place, more time will required to correct these errors. More control packets are exchanged. It takes place between destination node and source node to destination node. Time consumption process. Disturb the communication. This is the transport layer. Protocol is TCP, transmission control protocol. Depending on the type of protocol used in the transport layer attacks are classified. Type of protocol. Type means TCP protocol, UDP protocol. This one is reliable protocol. TCP is reliable protocol. UDP is unreliable protocol. Next, by interfering connection-based protocol. Example, TCP can be tampered. TCP is a connection-oriented protocol because before transferring the information from source node to destination node, a connection is must be created between source node and the destination node. By interfering this connection-based protocol can be tampered. This connection can be tampered. Connectionless protocol. UDP is connectionless protocol do not have sequence numbers or session number, and also do not provide error and flow control. UDP does not provide any error control and flow control mechanism. TCP provides error control and flow control mechanisms. Flow control means regulate the flow of data between source and the destination node. TCP is a connection-oriented protocol. UDP is a connectionless protocol. TCP is a reliable protocol. UDP is a unreliable protocol. In case of TCP, the data is divided into segments. These segments are numbered. These numbers are called as sequence numbers. In case of UDP, packets are not numbered. These packets are sent to communication network, finally reach to destination not in order. UDP is an unreliable protocol. Okay. How to disturb this connection between source node and destination node? By considering TCP protocol. TCP means transport control protocol or transmission control protocol. Transmission control protocol. At the transport layer, already I have explained TCP and UDP. These are the two protocols which are used to serve the transport layer functions. Consider TCP. Need not consider UDP because UDP is unreliable communication, unreliable protocol. A connection is established between source node and the destination node. The aim of that threat is disturb this connection. How to disturb this connection? Send wrong data, inject wrong control packets. Send wrong data, inject wrong control packets. Now we will see this one. Send wrong data. Sending up packets with wrong information enforces error correction on the receiver node. This is the source node and this is the receiver node. Sending up packets with wrong information. Wrong information packets are sent from source node to a receiver node. At the receiver node, check the condition of these wrong information packets. It will take more time for that checking. Okay, therefore the CPU power is also wasted and result into additional energy consumption. Suppose wrong packets are received, the receiver at the receiver side some buffers are used to store these wrong information packets. The receiver process these wrong information packets. Some CPU power is wasted. Time is also wasted, resulting in additional energy consumption. Second one, inject wrong control packets. Injection of packets into a running connection can enforce to close or desync or interfere the connection. Injection of packets into a running connection. Suppose these packets data is divided into segments. These numbers are 1, 2, 3, 4 at the source side. Suppose unwantedly some wrong control packets are injected. Numbered is 5. These are the wrong packets. Wrong control packets. Injection of packets into a running connection. This is the running connection. Can enforce a close. Automatically close this connection. Desync. Desync means establishment of connection is desync from source node to receiver node or interfere the connection. The packet injection process allows an unknown third party. Third parties are forcibly inject these wrong information packets into that connection. These packets intercept the packets from the consenting parties. 1, 2, 3, 4 are the genuine packets. Fifth one is the wrong packet. This fifth one wrong packet attached to these 4 packets and disturb the communication, closing the connection between source node and the receiver node. Intercept packets from the consenting parties that are communicating, which can lead to degradation or blockage of users' ability to utilize certain network services or protocols. 4 packets okay. 5th packet is the wrong packet. Disturb the communication between source node and the receiver node. This one is the transport layer attack. Tomography means examine the attacks at the different layers. Transport layer, generally at the transport layer, we use 2 types of protocols: transmission control protocol and user data UDP protocol, user datagram protocol. Transmission control protocol is the connection oriented one. UDP is the connectionless protocol. Aim of that threat is disrupt the connection between source node and the destination node in case of transmission control protocol. Sending the wrong data, inject the wrong control packets. Control packets means this is the source node and the destination node. Source node wants to send information to destination node. Source node send some control packet to destination node for accessing, send the information to destination node. Destination node is ready to receive data from the source node. Therefore, destination node send acceptance to send data from the source node to destination nodes. In this process, third parties are entered and inject wrong control packets from source node to destination node. Therefore, disturb the communication. Finally, the connection between source node and receiver node is disturbed. This is the attacks. Possible threats: send wrong data, inject wrong control packets at the transport layer. Next one, coming to network layer. Threats on network layer. The main aim of that network layer is route the packets from the source node to destination node via several nodes. A network is compromised of many nodes. Out of that, one node acts as a source node, another node acts as a destination node. In between these two, multiple relays are there. The main aim of that network layer is create the path between source node and the destination node. Attackers in network layer intends at disturbing and degrading the routing service. Route the packet. The main aim of that network layer is route the packets from source node to destination node. Route the information or packets. Attackers in the network layer intends at disturbing and degrading the routing service. Routing protocols are used to route the information from source node to destination node. Routing loop. The attacker simply forges new routing packets or modify existing ones to create a cyclic packet trajectory. This is the source node. This one is the destination node. In between some multiple nodes are there. The path is like that. This is the path. The source node having some packets like that. Instead of this one, these packets are attacker simply forges new routing packets. Instead of 4 packets, attacker creates another 4 packets like that. These 8 packets, these are the genuine packets. These are the forgery packets. These 8 packets are combined at the source node, and these 8 packets are not reached to destination node. Original information is not reached to destination node. These 8 packets are circulates in a cyclic path trajectories created like that. The attacker simply forges new routing packets or modify existing ones to create a cyclic. This is a cyclic packet trajectory. Cyclic packet trajectory. These packets cyclically transfers nodes and they never reach their destination. These packets are not reached to destination. Cyclically, a trajectory, packet trajectory is created like that. This type of attack shortens network lifetime by consuming valuable network resources. Each in that path, so many nodes are there. These nodes are waste their energies forwarding these packets to one node to another node to neighbor nodes. Therefore, shortens network lifetime. Shortens network lifetimes. These nodes are consumed more energy for sending the packets to neighbor nodes. Their energy is wasted. Finally, these nodes are in dead condition, shortening the network lifetime. This is the routing loop is created. Instead of this is a source node and a destination node. So many intermediate nodes are there. This one is destination node. A path is created like that. These packets are circulated and a routing loop is created. Finally, that important information is not reached to destination node. That is called as routing loop. Network partitioning is another attack at the network layer. This type of attack has the most serious impact on the overall routing service. The adversaries separate the network to disjoint set of nodes that cannot reach each other. This is the original network. So many nodes are there. This is the source node. This is the destination node. Network partition means source node is in one network and a destination node is in another network. Forcefully partitioning these the original network into two networks. This type of attack has the most serious impact on the overall routing service. There is no route to destination node after partitioning the original network. It can be achieved by injecting falsified routing packets or simply by other interventions that cause some nodes which are cut set nodes, the removal of which cause the network to partition. The original network is divided into two partition networks. These are some nodes are involved in one network, some nodes are involved in another network. There is no route to destination node from the source node due to network partitioning. Next, another important attack at the network layer is wormhole. Wormhole. Yep, this is the network. 1, 2, 3, 4, 5, 6, 7, 8 nodes are there in the network, but 2 nodes are created here. These 2 nodes are powerful nodes, consume more energy. A tunnel is created between these 2 nodes. Therefore, the attacker, this is the attacker node, extract the information from the first node. That generally here first node is the source node, 8th node is the destination node. Via routing, shortest path, the information is reached to destination node. That is by using some routing protocol concepts, find out the route or path from shortest path from source node to destination node. That is the actual procedure due to wormhole attack at the network layer. These are the attacker nodes. These are the two nodes or attacker nodes. Instead of this path, this attacker node extracts the information from the source node through tunnel only. That information is sent to another attacker node. Okay. Finally, that important information is not reached to intended destination node from the source node. Instead, attackers only see the information from the sent from the source node to attacker node, one attacker node to another attacker node. This is the wormhole. Routing loop. Routing loop means a circular create cyclic packet trajectory that disrupt the communication, shorten the network lifetime. Resources of these nodes are wasted. Resources means energy consumption is more, battery lifetime degrades. Finally, that nodes are converted into dead mode, not involved in any communication. Network partitioning. Imported network. Original network is divided. Suppose that network having a source node and a destination node. Due to that partitioning, the source node is in one network, destination node is in another network. There is no path to destination node. Therefore, finally, that information is not reached to destination node. A wormhole attack is the important attack at the network layer. A tunnel is created between the attacker nodes. Due to that tunnel only, that information is sent from one attacker node to another attacker node. A wormhole attack is caused by one, two, or more number of nodes. Okay. In one-ended wormhole, fake neighbors are created by establishing high power node. This is the source node. This is the destination node. So many nodes are there in between these. In one-ended wormhole, fake neighbors are created. This is the fake neighbor. Instead of this one, the path is like that. These are the fake neighbors are created. In one-ended wormhole, fake neighbors are created by establishing high power node. Establishing high power node. Two-ended wormhole is the most commonly found type of wormhole. Two-ended. This is the two nodes. It can set a via an out-of-band channel between two nodes or by encapsulating the packets. Here, a tunnel is the channel, out-of-band channel. A out-of-band channel is created between these two nodes. Two-ended wormhole. This is called as two-ended wormhole. One end overhears the packets and forward them through the tunnel. This attacker node extract the information from the source node through tunnel channel only, out of band channel only, send the information to another wormhole node. This is the finally that important information is not reached to destination node. This is the wormhole attack. This is a type of network layer which carried out to using more than one malicious node. Malicious node means unwanted nodes are introduced in the network and create the routing process. Disturbance the routing process. The nodes used to carry out these attacks are superior to normal nodes, and they are able to establish a better communication channel over long ranges. This is the normal nodes. This is the source node and this is the destination node. Via this one, a path is created. These are the normal nodes. Generally, attacker nodes or malicious nodes are powerful than these malicious nodes. powerful than these malicious, powerful than these normal nodes. These are the malicious nodes are powerful than the normal nodes. Provide better communication. Finally, important information is not reached to destination node from the source node. Next one, threats on MAC layer. These are the wormhole attack, routing loop, that means cyclic trajectory path, network partitioning. These are the possible threats at the network layer, disrupt the communication. Coming to MAC layer means avoid the collisions. Some MAC protocols are used to avoid the collisions. Spoofing, eavesdropping, buffer overflow, and operating system threat. These are the possible threats at the MAC layer. Now I will concentrate on threats on MAC layer. Spoofing. Spoofing means unauthorized parties may participate in the network. Example, by spoofing their identities and using the identity of another device. Another authorization means provide identity to the intended users, communicating parties. But in case of at the MAC layer, spoofing is the possible threat. Unauthorized parties may participate in the network and extract the spoofing their identities of their original communicating parties and using the identity of another device. This is the possible threat attack at the MAC layer. Attacks to the medium access layers are based on the shared medium characteristics of the broadcasting medium. Broadcasting media is the open one, shared by many nodes. A possible collisions takes place in this channel. This is called as broadcasting channel. To avoid that one, you have to create some MAC protocols. Next one, eavesdropping. Eavesdropping by nature is possible on broadcasting media. This is the broadcasting media. An attacker who is physically located within the transmission range of sender device, receives all the traffic and can read it unless there is no protection mechanism in place. This is called as eavesdropping. These are the buffer overflow, spoofing, eavesdropping, and operating system threat. Next, buffer flow. This one is the buffer flow. Next, this one is buffer flow. Such attacks intentionally force a buffer to store more data than it is intended to hold. The capacity of buffer is 2 megabits per second, 2 megabytes. Okay. Attacks intentionally force a buffer to store more data than it is intended to hold, greater than that 2 megabytes data. The overflow data can alter binary code and therefore the behavior of the node. Due to that overflow at the receiver node, binary code is also changes, alter the binary code, and also behavior of the node is also changes. Therefore, finally, that the communication is disturbed between the intended parties. Next one, Operating threat. Different threats like sensor threat, hardware threat, and operating system threats are also possible in IoT. Next one, operating system threat. Attackers attacks on the operating system can be categorized in attacks that wants to change the behavior of the nodes. Wants to change the behavior of the nodes, and in attacks that wants to disable the node, a critical service of the operating system. Finally, operating system threat means, due to that one, attacks that change the behavior of the node can be categorized into attacks that can be done remotely and attacks that require direct contact to the hardware. Direct contact to the hardware, do with the help of that one, change the behavior of the node. That is called as a operating system threat. Next one is a direct reprogramming. Direct reprogramming. Sensor nodes that can be directly accessed, collected, can be manually reprogrammed by changing applications, operating system services that are stored in RAM or ROM. Direct reprogramming. Some malicious sensor nodes are sensor nodes that can be directly accessed. Collected, can be manually reprogrammed by changing applications, operating system services that are stored in RAM or ROM. Next one, hardware threat. Here attacks are classified by direct electrical access to the internal components of the device. Direct access to the internal components of the device. Internal components means memory, processors, or like that. And also operating systems. That is called as a hardware threat. Due to that hardware threat, the behavior of the node are also changes. Sensor threat. Such attacks are classified by direct electrical access to the internal components of the device. For example, by micro probing. This attack is also called as a falsified sensor reading. Falsified sensor in wrong reading is obtained due to this sensor threat. These are the threats: buffer overflow, operating system threat, spoofing, eavesdropping. In RF layer, in radio frequency layer, hardware threat, direct electrical access to the internal components of the device, microprocessors, memory, etc. Due to that attack, hardware threat, the behavior of the nodes are also changes. Sensor threat is also like that. Next one, jamming, eavesdropping, replay attack. These are the attacks which are possible at the radio frequency layer. Next, coming to, okay. In case of eavesdropping, an attacker who is physically located within the transmission range of the sender device. This is the sender, this is the receiver, and an attacker who is physically located within the transmission of the, this one is the malicious node. An attacker who is physically located within the transmission range of that sender device receives all the traffic and can read it unless there is no protection mechanism in place. This is the malicious node, which this malicious node is very close to transmission range of that sender. This malicious node see the information reached to the source node. Examine the information reached to source node. Okay, na? This is the behavior. This is called as eavesdropping. Next, threats on radio frequency layer. Attacks on the radio can be subdivided into jamming, spying, and reply. Complete jamming. Due to increasing level of noise level, the communication becomes difficult and eventually impossible anymore. This is also one of the threat possible at the RF layer is a complete jamming. Noise levels are more increasing due to increasing level of noise level. The communication becomes difficult and eventually impossible anymore. For example, the communication of a group of sensors can be disabled in order to avoid propagation of alarm triggering information. These are the possibility of threats, possibility of the threats at different layers: transport layer, network layer, MAC layer, and RF layer. This is called as IoT security tomography and a layer attacker model. Tomography means examination of these attack possible threats at different layers. Due to these possible threats, disrupt the entire communication within the IoT network. With this, all the possible threats at the layers of that network are explained. If you like this video, please subscribe the channel for further updates. Thank you.